Hey everyone, welcome to Touch Tomorrow. If this is your first video, it's nice to meet you, and if you're coming back, it's nice to see you again. I'm Clarice, and in today's activity, we'll be exploring bottle rockets. Though some animals can fly naturally, humans rely on aerospace engineering, which is a field of engineering that studies vehicles that fly through the air. Aerospace engineers make technology like airplanes, helicopters, balloons, and even rockets. And ever since brothers Wilbur and Orville Wright made the first successful airplane on December 17, 1903, flying has become critical to international travel, space exploration, and learning more about the world around us. But unfortunately, rockets cost millions of dollars to produce, and it's not like we can go down to the grocery store and get a rocket when we want to. So the next best thing we can do is build it ourselves. The bottle rocket we're building today is a model of actual rockets, meaning that it's a smaller, simpler version of the actual thing. Though we won't be including all the components that a real rocket would have, we'll have essential parts like the fin, nose cone, and body tube that prove and show how rockets work. It'll help us answer a big question. What makes rockets fly, and what factors affect its flight? The materials you need today are 2 empty soda bottles of the same size, cardboard, tape, scissors, permanent marker, and cotton balls. First, draw a line around the top upper quarter of your rocket. The line should be a little bit above the soda bottle label. It doesn't have to be perfect, but it should be straight enough for you to follow. Next, follow the line with your scissors to cut the top off. Feel free to go back in after separating the pieces to remove any excess plastic. It should look something like this when you're done. Then, we're going to add some weight to our nose cone. Do this by stuffing 2 or 3 cotton balls into the bottom of your cap and taping it in place. Now we're done with our first soda bottle, and let's go on to the next one. Since this will be the bottle rocket's body tube, remove the label to make attachments easier to add. Tape the cut cap to the bottom of the second rocket. That way, the top of our rocket will be the nose cone, which is the green cap, while the bottom is the blue cap where we can add fuel later. It should look something like this when you're done. Now it's time to make 4 fins, a typical number for most rockets. These will span the entire flat part of your bottle rocket. You can use your bottle as a reference as you draw the triangle with your permanent marker on a piece of cardboard. Once you have a shape you're satisfied with, cut out the fins. You can use the first fin you cut out to trace and cut the other 3. This ensures that all your fins are the same size. Then, tape your fins upright to the rocket. Taping both sides of the fin to the bottle will keep it stable and in place. For each fin, rotate the rocket about 90 degrees before taping the next one. Make sure that all the long edges of the fin are flat against the rocket and that all excess tape has been cut off. You may need to go back and do this after an initial round of taping. Once you're done, here's what your rocket should look like. Congratulations! We now have a model of a real rocket. Our bottle rocket has a nose cone, which guides its direction and prevents air from slowing down the bottle too much. We have fins to stabilize the rocket while it's flying, and we have the body tube, which is the main part of the rocket and will store any fuel we use. This is just one out of a dozen different possibilities. What do you think could be improved? Would using different materials make the rocket easier to build? What if we used tissue instead of cotton balls in our nose cone? What if we didn't use soda bottles at all? Feel free to go back and test these different ideas by building more and more different models. So what exactly will make the bottle rocket fly? When the bottle rocket launches from its base, it'll move in the shape of a parabola. A parabola is basically a huge curve that rises, peaks, then falls again. This will be due to 4 forces of flight, something that keeps rockets, airplanes, and other aerodynamic objects in the air. Lift holds the rocket in the air, and will mainly be created by the fins of our rocket. Thrust is the force that directs our parabola and keeps our rocket moving forward. It will be created when there's enough pressure to build a reaction force inside the rocket to eject fuel out the back. And the opposite direction of thrust is drag, which is caused by the resistance between the air and rocket surface, effectively slowing the rocket down. And in the opposite direction of lift is gravity, a force that acts on all objects and pulls them down to Earth. When thrust and lift are the stronger forces, the rocket will move upwards along the parabola. When all forces are balanced, the rocket will fly towards or at its highest point. Once gravity and drag become stronger than thrust and lift, the rocket will begin to descend until it touches the ground. To see this for yourself, you will need your rocket, a pump, some water, some kind of base to keep the rocket upright, and a friend to help you. First, fill your rocket with water. Make sure to leave enough space for air to be pumped in. Secure the water in the bottle. Flip it so the nose cone points upward and the bottom is attached to your pump and base. Pumping air into the rocket will build pressure, as shown by the air bubbles in this bottle. Once the pressure is greater than the bottle can handle, it will eject the water and have enough thrust to start flying. Here's a clip of what that might look like. This is from several years ago, which is why the camera quality is definitely questionable.
3, 2, 1! 3.63.
After testing your own rocket and watching that video clip, what did you observe? How long did the rocket stay in the air? Did it go high or low? Did the weather affect its flight at all? How many pumps of air could you put in before the rocket ejected itself? Could you see the rocket fly in the shape of a parabola? Now that you have an idea of what to expect and how bottle rockets work, try mixing it up. What if we had a lighter model, or a heavier one? What if we put more cotton balls into the nose cone? Do you think the number of fins affects the flight? And if so, what's the best number? What if we used another liquid instead of water? What if we put more or less fuel in? Feel free to keep asking questions, write down your hypotheses and predictions, and then test them out yourself. Thank you so much for watching and participating in this activity. Enjoy the rest of Touch tomorrow!